In this video, you will learn about the effects on a graph. And this will be a short video. We're going to talk specifically about absolute value and how putting a number in front or inside the absolute value brackets, how it all impacts a graph. So let's just come up with just a basic absolute value here. We know that there is a number in front, and when you see no number in front of the absolute value, that insinuates the number is 1. And there's a number inside. Sometimes it's positive, sometimes it's negative. We'll call that B. And sometimes there's a number in back. It could be positive or negative. We'll call that C. Now, what does this A, this B, and the C do? And by the way, there's one other thing here that is hidden when you don't see it, and that is a plus or a minus. Now, they don't put plus signs, right? This should be a slash. There's a plus or a minus. When you don't see a sign, it's a plus. Just like when you don't see the A, you don't see a number there, it's a 1. So let's dive in and just discuss. We've already covered this in graphing absolute value, but now we're going to talk specifically about the changes. So I see 3 things. I see a 2, a negative, 3, and a 5. This first part here is going to describe how we take the original parent function and we're going to shift it in the opposite direction than you think. This inside describes a horizontal shift. We're going to go left or we're going to go right from the parent function. And it tells a lie. It's always a lie. It's opposite of whatever the inside is. So in this case, we are going to shift to the right 3 units. Horizontally, we're going to shift to the right 3 units. Now what you see in back describes a change of going up and down, referred to as a vertical shift. And this tells the truth, and back always tells the truth. So here we are going to go up 5 units. Well, now what does this front tell us? Well, if this is the parent function, its absolute value, there's 3 things that could happen. We may take this V shape and shift it left, right, up, or down, but the basic V stays the same. Or we may actually take that V and make it skinnier. When we say skinnier, really what we're doing is we're describing a stretch in values, stretch in Y values. Or we may take the V shape from the basic black parent function and we may make it wider or flatter. And in that case, we call it a compressed function because we're pushing it down. And we're able to look at the equation of a graph and make a prediction of what it's going to look like based on the number we see out front. If this number out front, and I'm just going to use the number symbol, if this number out front is greater than 1, not equal to 1, but anything greater than 1, even 1.1, anything greater than 1 is going to cause the parent function, which you see in black, to begin to become skinnier and stretch. The larger the number, the skinnier the shape. Now, what if that number is less than 1? So if this number is less than 1, but it still has to be greater than 0. So it's anything greater than 0 but then less than 1, then it becomes compressed. And again, the smaller the number, the flatter or the more compressed our shape will become. Now, it has nothing to do with being positive or negative, because if there's a sign in front, that represents totally 2 different things. If there's a sign in front, what it's going to represent is whether our shape opens up or our shape opens down. If it's positive, it opens up, and if it's negative, it opens down, which means we reflect it across the edge. Okay, we're going to practice the problems here. Oops. Doesn't matter which one you identify first, if you start in the middle or to the right or left, it doesn't matter. I just tend to have kind of a, for me, I think it's, you're going to find less mistakes if you do the same thing continuously. So I start in the middle, and part of the reason for that is I kind of want to know what is the vertex of this absolute value function. So this I'm going to do opposite, lies to me. So I'm going to go to the left one, and it tells the truth and back. So I'm going to shift down 4 units. Again, horizontal shift to the left 1, vertical shift down 4. And so many students are going to want to think of this as the same thing in front. These are actually 2 different things. There's the negative sign that said it opens downward. Another way to say that is you could say it reflects across the x-axis. It's important that you know both. So in your mind, yes, it reflects downward, which means this V shape is going to open down, but what is that technically doing? It's reflecting across the x-axis. This 3 is separate from that negative sign. Since 3 is greater than 1, it says that this shape that used to be like this is now going to get significantly skinnier. And then remember, it still needs to flip down, so it's going to look more like that. We're taking this V shape, we're going to shift to the left 1, we're going to shift down 4, make it skinnier, which means stretching it. And again, it opens. Okay, so like I said before, I'm going to start in the middle, but I go to the middle and there's no other number there. What do I do when there's no number there? Well, really, it's because there's a +0. That means I'm not going to shift left and I'm not going to shift right. But I am going to go straight up and back here. This back number is going to describe a vertical shift. So don't shift left or right, just shift simply up 15 units. Because this number is between 0 to 1, it means that my original V shape before I even do any horizontal or vertical shifts looks like this. And now, because this number is less than 1, I am going to start to compress this. The smaller the number out front, the flatter it becomes. It's referred to as compressing, vertically compressing or pushing down the function. Also, there's a hidden plus sign out front, and that means that it opens up. So I'm going to not shift it left or right. I need to shift it up 15. This whole thing would need to go up 15 units. I'm going to compress it, and again, it remains. I've taken away the absolute value function, so we have a function here. Again, I'm going to start on the inside. So this function says we're going to shift everything to the left 2. Remember, it lies to you on the inside. The back side is always going to tell you the truth. I'm going to shift down 5. These are two separate things. Because I'm not working this time I'm not working with the absolute value of V shape. Remember, the negative sign means it's going to reflect across the x-axis. And the 7 means because 7 is greater than 1, anything greater than 1, because it's not a -7, just 7. Anything greater than 1, we say, is going to stretch. It's going to rise at a faster rate. I'd like you now to practice the homework problems. Reach out if you have any questions over the homework problems.